We wanted to test different AI models locally to compare them and get reference points for their performance across various devices. So we grabbed our Pi hack, powered by the Raspberry Pi Compute Module 5 and a 256 gigabytes SSD, and got to work. We installed Ollama and ran several tests with different lightweight LLMs, and while some performed pretty badly, one of them genuinely surprised us. In this video, we'll walk you through the process and share our conclusions. You'll also find a link in the description to a full step-by-step guide on our blog, so you can replicate the experiment and use our benchmarks as reference. Welcome to Black Device YouTube channel. Before getting started, we needed to install Raspberry Pi OS on the SSD. To do that, we first had to make our computer detect the Pi hack as a USB storage device using its micro USB port and the RPI boot tool. Then, with Raspberry Pi Imager, we flashed the OS and configured the system to boot from the NVMe drive. Once ready, we connected the Pi hack to a monitor and keyboard and used the PoE Ethernet port to provide both power and connectivity. As soon as the system booted, we opened the terminal and found the device's local IP so we could access it remotely from our computer. Back on our Mac, we opened the terminal and connected to the Pi hack via SSH. We made sure the system was up to date and had the necessary tools installed. Then we installed Ollama, the client application that lets us download and run local AI models through simple text commands. We ran a few checks to confirm that everything was installed and working correctly. Next, we designed a small experiment. Test each AI model using the same two prompts and review the results they produced. To make sure we recorded all the stats we needed, we added the verbose parameter to our commands. On Ollama's website, we browsed the available models, reviewed their specs, and followed the instructions to run them. We started with DeepSeek R1, testing its 1.5 billion parameter model. When running our prompts, the model executed at an acceptable speed, but delivered very inaccurate results, even though our prompts were intentionally simple for lightweight LLMs. Then we tried the 7 billion parameter version, which took much longer to download and ran noticeably slower. It struggled with the translation task and, during the second prompt, fell into a loop that lasted over 11 minutes before returning an answer that simply wasn't worth the wait. We moved on to the 8 billion model, which was only slightly slower than the 7 billion version, but performed much better overall. Still too slow to be practical, though. Next, we tested Gemma 3, starting with the smallest model, just 270 million parameters. It downloaded instantly and turned out to be surprisingly fast and efficient. The translation felt very literal and a bit unnatural, but still correct, and it handled the second prompt easily and quickly. Then we tested the 1 billion model, which was also extremely fast and solved both prompts flawlessly. A huge contrast compared to DeepSeek. We continued with the 4 billion model, which was noticeably slower but still delivered perfect results. All three Gemma 3 models we tested worked well and were genuinely usable in our setup. Then we tried Ollama, downloading the 1.1 billion parameter version. This test failed badly. The model was fast but didn't understand our first query and hallucinated in the second one. Finally, we tested Phi 4 Mini Reasoning, the 3.8 billion parameter model. It took over 2 minutes just to perform the translation and fell into a reasoning loop in the second prompt, making it unsuitable even for simple tasks. In the blog post linked in the description, you'll find all the stats and a comparison table showing the performance of each LLM. In conclusion, we began this experiment to compare these models and, more importantly, to build a set of benchmarks we could use to test different hardware configurations. In the end, we were genuinely impressed by the performance of Gemma 3. Its speed and efficiency on such a simple setup, powered by a Compute Module 5 with 8 GB of RAM and a 256 GB SSD, were far better than expected for hardware that isn't designed for running AI models. We'll continue testing this Google AI model with more demanding tasks to see how far it can go on this type of device. If you enjoyed this project, try running the same tests on your own setup and share your benchmarks with us. Let's compare results and find the most efficient models for simple tasks on lightweight hardware. Subscribe to our YouTube channel for more experiments like this, and thanks for watching.